Welcome back, learners, and as I've said, we are going to look at our second concept now, which is the behavior of particles when we're either adding the energy or removing the energy. So, we know that matter can exist as a solid, liquid, or a gas, depending on the conditions of the temperature. We also know that particles behave differently when we either add or remove energy. So when we add energy into a particle, into matter, or when we remove energy from the matter, those particles making up that particular matter, they're going to behave differently. So in a case of this example given here, we have a solid, an ice cube, we have water, a liquid, and then we have gases there. When we add temperature, when we add energy onto this solid here, it is going to start behaving differently because the particles that are making up that solid are going to start now receiving energy from the surrounding, and when they do that, they start behaving differently. So when we add energy, there is going to be a physical change of these matter. They are going to move from solid, liquid, and gases. But not all of the matter can exist in all three different states. So there is a certain specific matter that can exist in all states. Others, they just exist in solid. Others exist in liquid, and others exist in gases. So what basically happens? When energy is added to a substance, the force of attraction between the particles weakens. Remember, the force of attraction, those are the attractive forces that are holding up the particles in a place. So we're saying that the force of attraction between the particles weakens, and then the particles will move away from each other. So once now that force start becoming weaker and weaker, the particles, they now start to break apart, move further and further away from each other. So they are moving that because they are going to be gaining energy, resulting in a physical change. So when we add, if you take a block of ice and you heat it, you add energy onto it, it is going to start to melt. If you keep on increasing that particular energy, that liquid, the ice is going to melt into a liquid. And if you keep on increasing energy from that liquid, it is going to turn into a gas, which is in the form of a water vapor. But then the opposite is also true. If we remove now the energy from gases, if you remove the energy from the gases, it is going to start to go back now to a liquid, and then from a liquid to a gas, which then means now the forces from a gas are going to start to be stronger and stronger and stronger. So once the force becomes stronger and stronger, the particles are going to approach each other and move closer and closer to each other up until they get to a solid. Now, to better understand this, I want to show you this animation so you can quickly understand what is going to be happening as you are adding energy and also moving the energy, removing the energy. Okay, now learners, so let's look at what we have here on the board. So we have our particle, which is neon, as our matter, and then we have our thermometer there that is going to be measuring the temperature as we either increasing or decreasing the temperature. That means when we're adding or removing the energy. And then we have our source of heat there that is going to be controlling the adding and the removing of energy. What I want you to notice is the behavior of these neon particles that we are having here when we're adding energy and when we're removing energy. Take note of the spaces between the particles, the movement, how do they move? Basically, we're looking at the behavior of these particles. We look at the spaces as we are adding or removing the energy. We're also going to be looking at the movement of these particles. So let's begin. So you're going to start by increasing. So we're starting from a solid. As you can see, it has a definite shape, and the spaces in between the particles is very small, and the particles are vibrating in a fixed position. And then when we are increasing the temperature now, the movement of particles starts to become more and more and more. And when that happens, they start to disperse into a liquid phase, whereby now the shape is taking, the particles are taking the shape of the container, and the spaces between the particles now will start to increase. And remember, once the space between the particles increases, it means the force of attraction, the force that is holding the two particles together, is also weakening. And then when we keep on increasing our temperature, notice that the thermometer up there, when we're increasing the temperature, the particles, they start to move faster and faster. The spaces between the particles, as we keep on increasing the temperature, it becomes more wider and more and more. So we're going to keep on increasing our temperature. You notice that now the particles are now filling up the container that we have, meaning that the particles are now in a gaseous phase. So now what happens if we were to remove this temperature? So the particles are starting from a gaseous phase. The spaces between the particles are very, very large. And if we decrease the temperature, notice the behavior of the particles, what happens to the spaces, and then what happens to their movement as well. So we are decreasing the temperature, Now the particles, the movement of the particles starts to get slower and slower as we are decreasing the temperature. And also note the spaces between the particles. It becomes smaller and smaller as we are decreasing the temperature. Note that, notice. So it is becoming slower and slower. And slower. So the particles are now approaching each other because they have lost the energy that enabled them to move around so vigorously. So they're starting to take shape, and the spaces between the particles becomes smaller and smaller and smaller as we are decreasing our temperature. So it goes back to a solid state. So it goes back to a solid state. And we notice again, if you're to increase again, it starts to move. And when it starts to move, the forces between the particles weakens. And as the forces weakens, the particles, they start to move away from each other, filling up the space. So they're moving from a solid, a liquid, to a gas. Now, I hope that was clear and it made you at least shed some light onto what is happening to the states of matter as these particles are transitioning from one state to the next. So now let's continue. So you have seen that what happens to matter and what happens to particles as we are adding energy or removing energy. So we are saying here that when a solid is heated, the energy of the particles increases as we have seen, causing more movement of the particles. We have seen that. And then the movement overcomes the attractive forces that is between the particles, and the arrangement of the particles will collapse. As we have seen, it started from a certain shape, and then when we're increasing the temperature, the particles, they moved away from each other, and that shape collapsed. So as we can see here, our solid, it is in a specific shape, and it is vibrating, but in a fixed position. Whereas if we increase now our energy, keep on adding energy to the solid, the particles are going to start to move around even more vigorously, but then they will not be in a fixed shape. So they will be sliding amongst each other, sliding across each other in a random direction. And also, if we keep on increasing the temperature on a liquid, the particles will gain more energy and move around even more vigorously and fill up the space of the container. Whereas in that case, the forces that are holding the particles together, they weaken up to a point where they're almost non-existent. So I hope you understood how the particles behave when we're increasing or we are decreasing the temperature, or when we are adding or removing the temperature. Now let's see what happens on our next concept. So our next concept is on diffusion, whereby we're going to be looking at the rate of diffusion and the factors that are affecting diffusion. So, but then before we begin, we need to know what is diffusion. What is this diffusion that you're talking about? So diffusion is a process in which the particles in liquids and gases, important in liquids and gases, move from a higher concentration, that means that are moving from many particles to a lower concentration to fewer particles until equilibrium is reached. That means until the particles are evenly distributed within the space. We have said that this is important, that the diffusion, it is happening between liquids and gases. Why not in a solid? Now, in a solid, the particles only vibrate about a fixed position, as we have seen that. Because of the strong attractive forces between them, therefore they cannot diffuse. Because there's a strong attractive force holding the particles together in a solid, the particles, they are unable to move, they are just vibrating within a fixed position. And because they cannot move, they can therefore not be able to diffuse. Right. In diffusion, what happens? The particles diffuse because they are in a constant motion. We know that the particle model of matter teaches that the particles are always in a constant motion. So they diffuse because of that constant motion. Liquids and gas particles can freely move, so because they can move, they can diffuse. But if it can vibrate, it can't diffuse. Diffusion occurs more quickly in gases than in liquids. Why does that happen? Why is it that? Because we've just said now that both liquids and gases, they have particles that are moving, and therefore in those particles, diffusion can happen. But then now we're saying in gases, diffusion happens more quicker than in liquids. Why does that happen? That happens because the particles in gases, they move very fast. Why do they move very fast? Because of the forces of attraction that are holding those two particles together. They are much weaker in gases as compared to liquids. So they move very fast in all directions, whereas the particles in liquid move slowly as compared to the gas particles. This is because of the spaces between the particles and because of also the forces that are holding the particles together. In liquids, the forces is strong as compared to the gases, but the spaces in gases is much more bigger as compared to the liquids. Hence why now in gases, diffusion happens easier as compared to the liquids. So now, if we were to take a dye and just pour a bit of dye in water and leave it there, that dye, it is going to move from a higher concentration from the moment you start pouring it in. That's now moving from that, because it's highly concentrated in that drop. So it's going to start moving from that drop, spreading across the container up until it has covered the entire container. That means when equilibrium is reached. So what affects the diffusion? What makes diffusion to happen? So the speed at which the particles diffuse depends on several factors. So the speed at which the diffusion happens depends on these factors. Number one, the mass of the particles. That now means lighter particles will diffuse faster because on average they move faster. So particles which have small masses, they diffuse faster because those particles, they're able to move even faster. Again, the state of the particle. So the state of the particle also affects the rate of diffusion. How does it affect? The particles in a gas are always moving fast, and we know why they're always moving fast, because of the force of attraction between the particles is weak, and also the spaces between the particles. We say that on average, the speed of the gas particles is very high, which then means now the particles in a liquid, they travel more slowly because of the force of attraction and the spaces between them. But those are not the only two factors that are affecting the rate of diffusion. The others are the temperature of the particles. We know that temperature is a measure of kinetic energy. Kinetic energy is that energy that an object or a particle has when it's in motion. So now, the temperature is a measure of kinetic energy of the particles. The higher the temperature, the more energy the particles have, and the faster they will move and diffuse. So once we increase the temperature, we are giving the particles more kinetic energy. And once they do that, they're able to move faster and faster. And when they're able to move faster, they can better diffuse within a space. Then the last one, the size of the space between particles. If there are large spaces between the particles of one substance, the particles of another substance can move into those spaces easier. So let's think of an example whereby now you're at school in an assembly, and there's like 1,000 people there in an assembly. You see that those people are closely packed together. It is going to be difficult for you to move from the back of an assembly to the front of an assembly because of the spaces between the people. So because of the spaces, the rate of diffusion, it is going to decrease. Now, with that said, learners, we've come to the end of our lesson. We have looked at different concepts from the rate of diffusion. We have looked at the behavior of the particles. We've looked at the particle model of matter. And throughout this lesson, I tried to explain what each of those things, how each of those things are interrelated to the particle model of matter. And with that said, I'll see you next time. Bye.